Hi everyone, welcome back. Today we are solving Trionic array 2. So we are given an integer array nums of length n, and we will be looking for Trionic subarrays, and it is considered a Trionic subarrays if we will have an interval where it is strictly increasing and then strictly decreasing right after it, and then right after that it is strictly increasing it again. And we want to return the maximum sum of any Trionic subarray that we can find in nums. So if we look at this example, the max that we can find would be to start here. It is increasing here, and then it is decreasing here, and then it is increasing all the way up to here again. And if we sum this up, it would be -4, so we return -4. In this example, the max would be to increase from here to here, decrease from here to here, and increase from here to here again, and then sum would be 14, so we return 14. So now that we have seen some examples, let's get to how we can solve this problem. So to solve this problem, we should recognize that there are 3 phases. Phase 1 is increasing, phase 2 will be decreasing, and phase 3 will be increasing again. And we should acknowledge that for phase 1, we don't need to include the negative numbers unless it will make the length of phase less than 2, because otherwise there will not be a phase 1. So if you look right here, we don't need to include -6 or -8. But let's say all of this is negative but increasing negative numbers, then we will need to keep whichever these 2 numbers are here, otherwise there will not be a phase 1. And also we should acknowledge that phase 1 can actually be phase 3 for another Trionic array. This can be a phase 3 because it's also increasing, and a phase 2 can actually come after phase 3. So this can actually come after a phase 3. It doesn't always have to come after a phase 1. These are just some things that we have to keep in mind for how we're going to code out the problem later on. So what we can do is we can initialize 5 variables, set phase 1, phase 2, and phase 3 to -infinity, and because of the ambiguity that we have mentioned here, we will also need to set a next phase 1 variable and next phase 2 variable set to -infinity, and we will iterate through the array. And we should acknowledge that next phase 1 and phase 3 can be calculated simultaneously because phase 1 can also be phase 3, and we want to keep track of the largest phase 1 plus phase 2 plus phase 3. In other words, the largest Trionic subarray. And we know that we have a Trionic array that we can calculate if we have finished calculating phase 3 and phase 1 does not equal -infinity like how it was initialized. And finally, we want to return the largest phase 1 plus phase 2 plus phase 3. So this is kind of broad, but I'll go more in details in the example walkthrough on how these variables will be kept track and calculated, and it will be in even more details when we get to the coding part. So let's go over this example real quick. So first we'll look at this phase. It could be phase 3 or phase 1. Now for phase 3, we'll set it to 9 because we will include this part. We will not include this one because we will count that as the last number of phase 2. So if you add this up, it will equal to 9, and this would be 8 because we don't include these 2 since they're negative numbers, and we only include these 3. This would be counted as the first number of phase 2. So if you add this up, it will be 8. Now we come to the next phase. We see that phase 2 would be 9, and we will count it as next phase 2. Assume it comes after phase 3 for now. So 13 minus 5 is 8 plus 1 is 9. Now we will move on to the last phase, and now we will set 8 and 9. We will put it in these 2 places as you will see. And next phase 1 will be 4 because we don't include these 3 numbers because they're negative, and we will include the 4, and this will be counted as the beginning of the decreasing segment in phase 2. And the next phase 2 is 9 because this will be the first number of phase 2. But now that we are at the end, we can add up these 3 numbers, which is equal to 27. So we can return 27 as the result. And the time complexity would be O of n, where n is a number of elements in the input array because that is how many numbers we will iterate through. And the space complexity would be O of 1 because the size of these variables will not depend on the size of the input array. So now let's get to the coding part. So first we'll initialize result to flow of -infinity, and we'll do the same for next phase 1 and next phase 2. And we will start at index 1, and while the index is less than the length of nums, now we will first check if the numbers are equal. If it is, and it breaks the strictly increasing and strictly decreasing rule, so we will reset phase 1 to float of -infinity, and same for next phase 2, set it to -infinity, increase the index, and continue. Now we will set total to 0 and phase 3 to -infinity and we will set phase 1 to next phase 1 that we have calculated previously. And now we will calculate the next phase 1 for the future. So initialize it to 0. Now we'll calculate phase 3 and next phase 1 simultaneously. So I is less than length of nums, and nums of I minus 1 is less than the nums of the current index. Then we will add that value to total. Now for phase 3, we will just set the max between total and phase 3. But for phase 1, if next of phase 1 is less than 0, then we will set it to 0. That means we will not include the negative number. And after that, we will add the number of nums of I minus 1 to next phase 1 and increase the index. Now, if phase 3 is equal to negative infinity, then that means we didn't even have a phase 3, so we will also set next phase 1 to float of negative infinity. And now we'll take care of phase 2. So first set phase 2 to next phase 2 that we have calculated previously. And now we'll calculate the next phase 2. So while I is less than length of nums and nums of I minus 1 is greater than nums of the current index, then we will add next phase 2 by nums of I. And now we will just check if we can update the result. So we will check if phase 1 does not equal to negative infinity. If that is the case, then we will set result to either the larger between the current result or phase 1 plus phase 2 plus phase 3. And finally, we will return the result. See if it works. Okay, perfect. Hope this was helpful. Thank you for watching. If you have any other questions or comments, feel free to leave them in the comment section, and I hope to see you all again soon.